Everybody, this is Larry doing day 10 of the 30-day Leetcode challenge. Yeah, we'll just jump right into it. Let me know how you solved the problem in the comments. Hit the like button and all that stuff, I guess, as well. Uh, min stack. Design a stack that supports push, pop, top, and retrieve the minimum element in constant time. Okay, so this is a min stack. And this is what it sounds like. So what I would do is just have two stacks. I think that's the canonical one. This is a little bit of a well-known problem, um, and the key thing is just to make sure that again all these operations are done in constant time. So let's kind of play around with that idea. So now we have a regular stack, which is nice as well. And then the min stack. I guess to keep it consistent, technically I use the other case. And also debating using a send and no value, which I guess is okay. We'll just have more cases to check. On push, what happens? Well, on a regular stack, we just push it on a so if the length of stack is equal to 0, let's just put it on top or at the end because I'm using an array. Otherwise, what's the other scenario that we want to put on top? If this is the new min that we want to put on top, right? So this is the new min if stack, the top of the stack is greater than x, right? All right, let's get the top first because that's easy. So let's just return solve.stack 1, so now I'm just looking to see what to return if the stack doesn't have that many length. I guess in theory we would put for an exception, but it's not defined on this problem. So I guess let's just assume it doesn't happen, maybe. Actually, we could do it this way, but I'm going to do it another way just because I'm a little bit lazy on handling all the other cases. Let's on the min stack, let's append the minimum element of the top element and then x. So I did it this way. Now I changed the code a little bit. Just the reason there is now there's an invariant in which the length of the stack is equal to the length of the min stack, which makes our pop a little bit easier to write. Because now we could just do we return on pop? I guess in this case it's none, but depending on an API, some pop actually returns the top value as well, but it seems like in this case that's not necessary. So let's I just remove it then. And get min, we just return the last element, or the top element of the min stack, which is by definition the min in the array or in the stack. Again, I'm just trying to see if like what is the error handling case? What is the what to return when the length was 0, which I guess they don't give you again, which is kind of odd. Maybe we'll play around the test cases then. Oh, whoops. Did it the other way. And this is why we test. Cool. Okay, now let's test some. I mean, there's definitely a lot of edge cases. I think in theory, in comparative programming, maybe I'm a little bit confident I would just submit this because this is also a little bit annoying to set up. But let's do, like I said, like let's do a pop when there's nothing on the stack, and then see what's the expected value. I think my code would just crash, but yeah, I mean my code should just crash. I think I should throw an exception, but it's not defined what the answer should be. Maybe let's just return 0, maybe. Huh. Yep, one-time error. 0 is actually a little bit bad for this return value because I think maybe it could be like, I don't know, negative infinity or something like that. Let's do that. So similar, let's test a case where we do get min on an empty array, and then we can also play around variations of that, of course, getting to that 0 state. This one thing is to look at this example case, and is way minimal, and perhaps not correct. Pop from empty list. Did I do it again? Oh, that's the one that I didn't check. Oh, okay. Well, I guess they just don't give you an answer because they crash on this side. All right, let's just submit then. There are no edge cases for those. But of course, if you're an interviewer, I would definitely recommend talking through that and be like, hey, because well, you can really ask, um, Leetcode or whatever how to handle these on an interview. You definitely should spend the extra 10 seconds. Like, hey, so how, what is the case if the stack is empty, right? Like, what is the like, what should our problem return check for an exception? I think the clean way is probably the way that I would write it if it was production code is for an exception here. I actually don't, it's been a little bit. I forget how to for return exception anymore. Is it just something like, I mean, you would write a name type or something like that, so it won't be like a generic exception, but something like that maybe. Um, so similar there. So I would talk about how I would for an exception, and how maybe we'll talk about what an exception is Python, and you know um, whether it's Pythonic versus some other languages. Because in Python, it's generally very pro throwing exceptions versus another language exception is supposed to be less on the control flow. Um, yeah, so you could usually see that this is constant or one time for every operation because, well, creating a stack is free, or not free, just like one operation or two operations if you want to go like that, or two type of, and everything here just, um, yeah, everything is all one, assuming that, you know, and this is the correct assumption that underlying data structure. This is the case in Python where adding an element at the end of the array is constant time. Your data structure may vary, but you can also use your class stack or your language stack library, and it'll give you the same rough thing, um, same performance profile. Um, yeah, and top always just look at the end of the list, so that's constant time, and get min also look at the end of the other list, so also constant time. So yeah, everything's constant time. Linear space because it can grow as much as n, but 2 times n, which is O of n, and yeah, and there you have it, min stack. Let's take a quick look at the hints to see if we're missing anything cool. Consider each node in the stack having a minimum value. Oh yeah, I guess you could put it actually on the same stack and then having, a tuple or something like that, but same idea really. Um, and you actually don't need to append for each of that. You do some special handling so that you only pop up the min stack if it's equal to the top of the stack, but it makes your pop a little bit more complicated to write in error prone. But yeah, but that's all I have, I think. So, right, thanks for watching. See you in a bit.